Hi viewers, in my last two successive videos, I concentrated on the percentage change problems with variations of less than 5% and greater than 5%. This video, I'll be allotting for percentage change problems where the quantities are related inversely in a given formula. Now let us start. See, I'll explain two examples how to solve this kind of problems. Let me start with example 1. We are taking up a question in a competitive examination. Let it be like this. At constant temperature, if the volume of a gas decreases by 20%, what is the percentage change in pressure? I am repeating the question. At constant temperature, if the volume of a gas decreases by 20%, what is the percentage change in pressure? Let us start. We know from Boyle's law that pressure of a gas is proportional to 1 by V, where P is pressure, V is volume. Implies PV is equal to constant. Implies P1 V1 is equal to P2 V2. Now let us go to the next step. Therefore, P2 by P1 is equal to V1 by V2. The question says that the volume of a gas decreases by 20%. So, if V1 is equal to 100, V2 is equal to 80. We'll assume that all numbers 1 represent initial, numbers 2 represent final. This implies P2 by P1 is equal to V1 by V2, which is equal to 100 by 80, which is equal to 10 by 8. Now let us subtract 1 on both sides. So P2 by P1 minus 1 is equal to 10 by 8 minus 1. We'll multiply on both sides by 100. We have P2 minus P1 by P1 into 100 is equal to 10 by 8 minus 1 into 100, which is equal to, see, this is 10 by 8 minus 1 is 2 by 8, which is 1 by 4 into 100, which is equal to 25%. So summary of the discussion we have had is, if the volume of a gas decreases by 20%, it implies that the pressure of a gas increases by 25%. This is how we'll solve the problems where the quantities are related inversely in a given formula. I'll continue the discussion with another example from another chapter. I hope this is clear. Once again, as I told you in my last videos, to have clarity, I wrote so many steps, but once we are familiar with the steps, it does not need so many steps. You can solve it in less than half a minute. I'll take up the second example with another question in a competitive examination. Let us say the question is like this. If the distance of separation between two bodies increases by 20%, what is the percentage change in gravitational force of attraction? I'll repeat the question. If the distance of separation between two bodies increases by 20%, what is the percentage change in the gravitational force of attraction? Well, we'll start. We know that NULG, Newton's universal law of gravitation, states that the gravitational force of attraction between two bodies is given by F is equal G m1 m2 by d square. This implies that force is proportional to 1 by d square. Implies F d squared is equal to constant. Implies F1 d1 square is equal to F2 d2 square. Now from this, what we will do is, we will take up F2 by F1, which is equal to d1 square by d2 square. Now, the question says that the distance of separation increases by 20%. So, if d1 is taken as 100, it implies d2 is equal to 120. We'll substitute here. F2 by F1 is equal to d1 square by d2 square, which is equal to 100 divided by 120 whole square. Zeros get cancelled, so we have 100 by 144. Let us subtract 1 on both sides. We have f2 by f1 minus 1 is equal to 100 by 144 minus 1, which is equal to minus 44 by 144. Let us cancel 4 in numerator and denominator. We are left with minus 11 by 36. We'll multiply both sides by 100. We have f2 minus f1 by f1 into 100 is equal to minus 11 by 36 into 100. We'll cancel 4 9 times, cancel 4 25 times, which gives minus 275 by 9, which is approximately minus 30.5%. End of the solution. That means, so the summary of the discussion we have had so far is, if the distance of separation between two bodies increases by 20%, the gravitational force of attraction between them decreases by 30.5%. You know, in the final solution, we had on the RHS a negative value. The negative sign indicates that as the distance of separation increases, gravitational force of attraction decreases, and vice versa. Well, with this, I have completed one kind of a probable question in a competitive examination dealing with percentage changes in physics. Good day. Thank you.